Hello, and welcome to a Vulkan LOKRING sealed system repair presentation. My name is Jesse Lentini, and I'll be guiding you through a sealed system repair using LOKRING products on an Electrolux tall twin refrigerator and freezer. This repair should only be attempted by a professional technician. Before you begin removing any components of a sealed system, you must first ensure that you have properly evacuated the system following your federal, state, or local regulations. We start by removing the evaporator from the freezer portion of the tall twins. However, it is the same steps you will follow no matter which evaporator or brand you are working with. To remove the evaporator, you first want to start by cleaning the area of tubing with abrasive cloth in the section where you will be cutting and rejoining your tube. This ensures you have removed any oxidation or contaminants. After cleaning the tube, use a permanent marker to mark the place where you will make your cut using your LSRZ 120 degree cutters. When using LOKRING, it is important to leave as much tubing as possible to ensure you have enough to complete your connections. For this repair, the factory brace joint is not leaking, so we are going to leave it intact and make the cut further down the line where it will give us parallel tubes, making the assembly process easier. After we've removed the evaporator, we need to prep the replacement component. From this point forward, we will be working on the refrigerator portion of the tall twins. Here you can see Bill following the same steps as when we removed the evaporator. First cleaning the area where we will be cutting and marking the cut location with a permanent marker. For this first cut, he marks right before where the tube begins to swedge down to ensure that he has even tube measurement. For the outlet tube, you can see that he uses the old evaporator to mark and measure where he will be making his cut on the new evaporator to ensure that he has left enough tubing to complete his connection. You'll notice that Bill uses a small punch to help even out the diameter of the tube, which took on a slightly oval shape due to the cutters. This is done to ensure that the tubing will slide into the connector with ease. After placing the evaporator into the unit, we see that Bill has removed the rings from the body of the 00 LOKRING connector to make it easier to assemble the connection, as it is close to the apex of a bend. This can be done by using a set of pliers and a twisting action, similar to removing a bottle top. If he left the rings on the connector, he may not have been able to fully insert each side of the tubing to the center stop of the connection. He applies the required amount of lock prep to each end of the connector and spins it 360 degrees to ensure that lock prep has been evenly distributed, and then uses the HMRKV to close the connection. When using the HMRKV or the Lock Press Mini, it is very important to ensure that the rings of the connector are seated firmly inside of the jaws. Notice how Bill has the fixed handle on the left side and is using his fingers to press against the tube. He does this so he is sure that the tube coming from the evaporator and the outlet tube are pressed all the way into the center stop of the connection. He also braces the handle of the HMRKV against his forearm to stabilize the tool, preventing the jaws from slipping off of the rings of the connector. Moving on to the inlet tube, Bill removes the rings from the body of the connector on the side of the tube where the bend is, doses with the required amount of lock prep directly where the body and the insertion tube join together, rotates the connector, and brings in the HMRKV to make the assembly. Once again, he uses his forearm to stabilize the tool and keeps the tube fully inserted by holding it with his fingers. After making a couple reductions, he removes the tool, flips it over, and then finishes closing the connector. This allowed him to place the tool into a more convenient position where he was able to get larger strokes with the ratcheting arm of the tool. Afterwards, Bill cleans up any excess lock prep with a cloth. Moving on, we will be replacing the compressor and filter dryer. Whenever you replace a component of the sealed system, you must also replace the filter dryer. Bill starts by cleaning the tubing surface with abrasive cloth. It's important to clean your tubing before making cuts, as this prevents any debris from falling inside of the tubes, as well as keeping the tubing stabilized, making it easier to clean. Notice the way that Bill has the abrasive cloth cut into small strips, wraps it fully around the tube, and uses a sawing motion to clean all the parts of the tube. Here Bill uses the LSRZs and keeps them nice and parallel to create an even score mark, and then uses a set of pliers to snap the tube. This helps prevent any burring or ovality from occurring on the tubing. You can also place your finger along the edge of the cutters to help guide them as well. If your cutter slipped, just place the cutting wheels back into the groove that you have already started and continue making your score mark until you're able to snap the tubing evenly. To prepare the new compressor for installation, Bill cleans the ends of the stubs with a Scotch-Brite pad and then measures the replacement compressor stubs so he can select the correct size connector to use. Once we're ready to move the compressor into the cabinet, he also measures the tubing on the unit to get the correct size. When using LOKRING, you must use a set of calipers set to millimeter. Generally speaking, there is only a tolerance level of plus or minus 0.2 millimeter between the inner diameter of the connection and the outer diameter of the tubing, which is why it is imperative to get correct measurements and finding the correct connection to use. After taking his measurements, you can see Bill preloading the condenser tube to help make the assembly process easier, similar to what you would do in a brazing repair. Once again, he removes the rings from the body of the connector, inserts the tube, and then marks the edge of the tube where it just comes out of the connector, removes the tube, and checks his mark versus where the center stop of the connector is. This process helps the installer be sure that the tube is fully inserted against the center stop and is not backed out. After closing the connection, the mark should still be in the same place, just outside of the body of the connector. After bending the tubing and getting it into a position where he is confident that the tube will not move once inserted, he doses with the appropriate amount of lock prep and proceeds to close the connection using the HMRKV. You can see here how he uses the fixed handle opposite of the fixed object, in this case the compressor, to start the assembly, and then changes position after making a few compressions. Moving on, we move to the copper suction tube. Bill once again removes the rings from the connection, inserts the tubes, and marks his connection point with a marker. Here you can see he removes the ring from the other end as well to help compensate for the slight bend in the tube. He then brings in the HMRKV with the fixed handle opposite of the compressor, stabilizing the tool with his forearm, presses the tube all the way into the center stop, and fully closes the connection. We are now ready to install the service port onto the compressor. Due to having limited space, we can see that Bill is measuring the length of the service port and then removing excess tube off of the compressor stub and the service port so we can be sure that we have enough room to reinstall the condenser fan. Bill cleans the tubing with Scotch-Brite pad to remove any grooving or contaminants that may be present in the material. He preloads the HMRKV and proceeds to apply the appropriate amount of lock prep. Because this connection is in a slightly vertical position, we first dose the bottom tube, and then slide the connection over the tube, and then dose the top tube, allowing gravity to work with us, pulling lock prep into the connector. After dosing, we follow the same procedure as before, starting with the fixed handle opposite of the compressor for the first couple of compressions, and then flip the tool to be able to get full strokes of the ratcheting handle until the connection is completely closed. We are now ready to make our last connection, the filter dryer. You can see the Bill is carefully measuring the hot gas line, as well as the aluminum capillary tube. Due to the aluminum material, you will want to take extra care to not bend the capillary tube, as it is quite easy to break. Bill then measures the stubs on the replacement filter dryer to determine which size lock ring we will use to complete our repair. Connectors for capillary tube are available in size ranges from 1.3 mm to 3.2 mm. 1.8 mm and 2 mm are the most common capillary tube size used in the United States. Due to capillary tube connections having a tolerance of plus or minus 0.1 mm, we must use a set of calipers to determine the outer diameter of the capillary tube and then use the fit doesn't fit check method. This means if the capillary tube measures 1.9 mm, you will first attempt to use a 1.8 mm connector. If you are unable to slide the tube through the connector, you will then use the next size up, a 2 mm connector, to complete the repair. Once again, Bill cleans the tubing using Scotch-Brite pad to remove any scratches, grooves, or contaminants from the filter dryer. He uses the LSRZ 120 degree cutters to score the ends of the filter dryer and then snaps them off. He test fits the connections to ensure that the inlet of the heat loop and the filter dryer can be fully inserted to the center stop of the connector. Then he uses capillary tube cutting pliers to cut off the end of the capillary tube. Take note that when using the capillary tube connections, there is no center stop, so you will slide the capillary tube through the connector, with it protruding about 1 mm out of the connector. Because the aluminum material is fragile, we do not want to bend the tube as you normally would with copper tubing. Instead, we mark the tube with a permanent marker for a reference point for the insertion depth needed. Because we are joining aluminum tube, we will be using an aluminum connector. Bill is now centering the aluminum tube inside of the connector as best as he can so he can insert the dryer stub. He then doses with lock prep and completes his connection. Notice how Bill has the HMRKV braced against his forearm and uses his hand to ensure that the filter dryer stub does not back away from the center stop. He then doses the next connector in the horizontal position to make the dosing process easier. To prevent the capillary tube from snapping, Bill cuts the joint in the palm of his hand and then moves the filter dryer into position, doses the top portion of the connector, and braces the tool with his forearm, making 3 compressions, and then moving his hand to the back end of the handle to complete the repair. After waiting a minimum of 10 minutes, we will then be ready to pull a vacuum or pressure test our repairs. Cure times are dependent on the ambient temperature of your work environment. Thank you for your attention through this presentation. For more free training and product information, please visit the LOKRING knowledge base by scanning the QR code or visiting lokringtech.vulkanusa.com, where you can find more information on proper sizing, lock prep dosage, and cure times.